Yo chat, what's up? I'm also scared that I have a dead pixel on my screen, but in fact it's just dirt. Oh, I forgot. Wait, give me a moment. A little lighting that I have, I forgot, of course, but you didn't notice, I think. Maybe just a little. Yo. What are we even doing? I don't know. We could do some writing, but I'm not sure. I'm not sure. I'm not sure what we'll be doing. So we have some options. There are some options on the table. I could do some animating myself. I haven't done that in a while. I usually just fix code in the library and I never get to do my own animations, which is kind of sad, but this is how it is. I think the last actual animation that I wrote was my channel point reward. The most profit. I think that's the last proper thing that I did. Oh, yo, now I just see my t-shirt is too green. Oh no, that's terrible. Actually, it's the one that I got from Hacktoberfest, which is pretty nice. From maintaining the library. These kind of things are pretty cool. So that would be one option. I could do some animations myself, because there is actually something that I would like to have animated. And it would involve some nice trees. So that's one option. Other options could be... There are a few open pull requests that we could look at. I guess we could even... Yes, so that would work. Yo, Tolkirche, what up? Hyped? What are you hyped for? How was compiler construction? Oh, oral exam today. Nice. And you are hyped, so it went well, I suppose. Ooh, student assistant. Nice, fancy, fancy. Over at the computer science department? A-Inf? Hawk indeed. Congratulations. Pretty neat. Topic sounds rather complex. I mean, complex can be fun sometimes. As long as it's not fix Manim, should be good. An ASP solver with lazy grounding. Ah. The logic, guys. I see. That's fun. So you're gonna accept? You sound like you would like to. Probably yes. Cool. Then we'll be colleagues. Open source project, nice. I'm sure. Yo. I shouldn't start scrolling Twitter, otherwise I won't do anything. What's the plan for today? Yeah, I don't know. That's the problem. I baited everyone here into the stream to help me decide what I should do. Yeah, I'm also fine with just sitting here and chatting. That's actually fine. But I do want to do some Manim work actually. The question is, wait. Oh, I'm holding a green clip right now, and I'm really confused. You can see it when I hold it like this. And I was really confused about my green screen again. So option 1 would be, I have actually some stuff that I would like to animate myself. I also got some good news today, and there's a thing that I would like to produce in order to celebrate that actually. So that would be one option, to work on something like that. And the other options involve, well, actually maintaining the library and looking at some stuff. Because I just mentioned earlier, I think the last time that I actually wrote an animation myself, or the most complex animation that I did recently, was probably the Moss Prophet channel point reward, which is not, well, that amazing. It's been a while since I actually did a proper animation. So that might be fun. Other options include, well, looking at pull requests and merging some stuff. I could write up the latest YouTube video I uploaded. Actually was much better received than I anticipated, even though it's 3 hours long. And you're in it actually as well. Stream is in it. Pork. So that would be an option. We could look at. We could continue writing that guide. Not sure how exciting that is. Chat is featured. Indeed it is. And the last option would be... Wait, what was the second to last? The last option would be doing some related things like going over the library and fixing type hints or something like that. Something that doesn't require too much processing mental capacity, because I am lazy. So yeah, these are kind of the options. What would you guys like to see? We could just work on the library a little bit. We'll actually start sharing screen, because I mean, you're not here to just see me. You're here to see code, right? That's what everybody always tells me. Both first and third sound really cool. So I could do some tree stuff. Maybe that would be fun for the beginning a little bit. I'm for option 1. Aha! I could do that in a little while. Maybe let's do it until I get bored. We could do that. Okay, let's start. Git checkout main, git pull. So basically I need to figure out some things. And the main thing that I will have to figure out is I have a rather particular animation in mind that I want to do. And we will have to think about how to actually do it. That's basically that's the most unconcrete description that I could possibly come up with, I guess. Okay, we make a new file. We put it in example scenes so that everybody gets mad at me again next time. Let's call it. Let's increase the font size a little bit because I'm old and I can't see well. Wanna become famous? No thanks. Already am. Oh, you are fast, Valkisha. Okay. Tree.py. We save it in example scenes. Go. Oh, those poor viewbots. One less in my channel. A lot of viewbots actually. I mean, sort of viewbots, but not really. Viewbots would be good for me. Well, good. Actually, not. I don't like. I mean, what do I have from the number being bigger? The number of viewers being bigger? Nothing. It's the people, of course. I'll probably just connect to the Twitch IRC server. Yeah, definitely. I actually played around with the Twitch interface, with the Twitch API a little bit a while ago, but I wanted to do something in particular, but I got lazy and then didn't. I did want to write my own chatbot at some point, but guess what? I implemented my own Twitch alerter. Ooh, fancy. That's fancy. The Chrome extension. Wow. A Chrome extension. It's pretty cool, actually. Okay, so I'll do something. While I chat with people. Really useful, actually. I guess so. So we have a file. We have a file tree.py. We can remove that. We can also make that a little bit smaller because I don't need it immediately. Probably the only tool I developed that I still use after years. Oh. Yeah, it's fun. Sometimes you just do really like local solutions, let's say. Okay, here's the thing. I want to visualize a large random tree. Large random trees, we can use network X for the generation of the tree. And I'll just generate one and show you how it looks like, and then I'll actually tell you how I want to animate it. And then we'll do all sorts of fun things. So, from Manim import star. Import network X as NX. Class large random tree scene def construct self. Okay, I'm tired already. That was exhausting. Now let's find out. Let's find out how stuff works. Python import network X as NX. First I have to figure out how the random tree stuff works, but I've done that multiple times already, so it shouldn't be that hard. I think it's like nx.random tree. There it is. Easy. And then I give the number of vertices, I think. We can start with like 20 or so. Yeah, okay, that works. So nx dot nx tree equals nx random tree with, let's say, 20 vertices. There will be a whole lot of automation later on, but not now. Later on. So, and then we use the stuff that Manim already has implemented for graphs. So I say I want a graph. Actually, let's call it T. T is a graph from network X, which gets an X3 as an argument. And do we want to have any? Yes, layout actually. The layout should be a tree layout, and the root vertex should be the vertex labeled 1. I think the so G equals this thing, G dot vertices. What's the nodes? Let's look at call it nodes. Yeah, 0. 0 is the root vertex. Okay, and then let's look at the thing. Let's open a second terminal. Example scenes Manim QMP tree large random tree. There we go. Pog. Okay, so we have a large, I mean not really large. This is like 20 nodes. Let's do like 200. We can actually see, I mean large random tree and then 20 nodes is not appropriate. Yeah, much better. Much better. I do have to increase the layout scale. Layout scale equals 4, which makes it fit in the box of in a 4x4 box. Right. Almost good. Maybe a bit less than 4. Maybe a little bit less than 4 actually. So let's take 3.9. If I were a professional, I would make this dependent of the node radius actually, but I'm not professional obviously. All right, so we have a nice random tree. What I want to do now is modify this a little bit because the vertices, the nodes are currently a little bit too large for my taste. So what we'll do is we will take this and pass more parameters. Pass more parameters, namely we pass vertex. How is it called? I should maybe look up the vertex config. Yeah, vertex config. Vertex config. I know that the little nodes are actually well, circles in the end, actually dots, and dots have a radius, and I can adapt the radius by saying radius should be, I don't know, 0.1 maybe that is even larger than the current setting. I don't actually, yeah, it's larger. Let's make it half that, 0.5. Yeah, that looks clean already. I like it. And now we will also, I think we will also decrease the edge width a little bit, because that's a little bit too thick for my taste. Actually, we could also probably, I will see, we'll see. That should be edge config. And the appropriate parameter is probably stroke width. The units are wonky. I don't know exactly, but this could be, I think this could be actually pixels or something that resembles pixels. So let's take 1. Yeah. Bit more maybe. 2. Okay, we're getting somewhere. I feel. Yo, chat, what do you think? thicker edges, slightly thicker edges maybe. This is a bit unfortunate. Still some slight overlap here, but I'm not sure how easy we could fix that. No, okay. Okay. Actually, so this is an animation library, so let's actually do something that looks like an animation. We could. One fun thing that I like doing is rerouting the tree. It always looks so fancy. Give me your favorite number between 1 and 200, chat. First one wins. $42. That's the only correct answer. That's the only correct answer. We changed tree layout. Exactly. Other Catalan numbers would have also been acceptable. Okay, we changed the layout of the tree. 69 is not a Catalan number. Alright, and the root vertex should be 42. And then we actually animate it. Runtime equals 3 seconds. Okay, let's look at it. It's always so fun. Not actually the animation I want to do, but it's still, it's a good one, I hope. Oh, I forgot we have a large object, so the stuff takes a little while to render already. What's the next Catalan number after 42? Is it like... I'm not sure I would know. Yo, why is the tree too large? That shouldn't happen. Oh, it's actually not. Okay, here we go. Rerouting, please, in 3, 2, 1, let's go. Oh, it's stupid. That's annoying. I mean, it looks fancy. 132. Ah. Yo, let's fix that. Doesn't look good. So what we will do is we will add a graph config dictionary, which we will fill with the entries that we had here. These go here. What do you Just want to say, what do you complain about? But I actually can see what he complains about. This is this, and this is this. I hate that you have to specify stuff like this, but it's how it is. Graph config. And then we put the stuff here again. Okay, second try. We re-render. Let's go. Change layout got an unexpected keyword argument vertex config. What can change layout do? That's weird. Is it really just the layout skill changed? I feel like the edge config also changed. Wait, what? Wait, what? Oh, well, that's... No, it actually shouldn't. It shouldn't change the widths and stuff. So actually it was just the layout scale that was fixed. Well then these two can actually stay here. Ah, reverting. I hope at least that works. We'll figure. We'll see in a moment. But then I have to specify the graph config is here. All right, should work now. Please. See, that was the problem. I didn't say please before. Manim's a diva? Yeah, definitely. You didn't know? Okay, new tree. Here's the tree. Let's transform it. Swoosh. Yeah, that's much better. Again. Ooh. Ooh. I really like how the different parts move around. That's pretty satisfying. Swoosh. Yeah, it should definitely, if there's a sound effect, it should be swoosh. Swoosh. No, it's pretty neat. Okay, so that's sweet. What would I like to do next? I actually didn't want to I just wanted to show you how the change of the layout looks like. Another thing that's actually fun, you can also change the layout from, if the original one is not the tree layout, but the default one, and then we change the layout to a tree layout. That's also fun to watch. I'll show you that as well. Increase the runtime a little bit. Maybe add a weight in the end. The default graph drawing algorithm is like a spring layout where the vertices and edges have like a... the vertices are treated as mass points and the edges are treated as springs, and then it just tries to gravitation and stuff. And I don't know physics. I have no idea. Just works. Looks pretty. So it looks like this first, and then you bring structure into it, and it looks pretty neat. Yep. I feel like this is probably one of the most satisfying things that Manim allows you to do. Bringing to something that looks completely chaotic and doesn't seem like it has any sort of order, bringing order to that by just applying the tree layout algorithm. Swoosh. Yeah, it's pretty sweet. I agree. Definitely agree. Yo. So. More nodes? Yeah, definitely. I think we can do like 500 easy. The rendering will take a little while though. We could try whether Opengl rendering is better. I'm actually curious. Yo, Archimedes. Very nice. Thank you. I also think so. Show me more nodes. Yeah, that's how it is. Okay, let's go. I expect something satisfying. Let's put this here. Ooh. But then for 500 nodes, the node size is too large again. The tree needs a little bit more, space to breathe. So these should be decreased a little bit. But overall, also very satisfying. We could, of course, one thing that we could try is actually reducing the... We could try reducing the node vertex size to 0. So So we could try to reduce the radius to actually 0, which would mean that we only see the edges. Sometimes this has a nice look and feel to it, especially if you have very large trees. Just have to move around a little bit. Can you curse into a more balanced tree? Only if I. So right now I'm choosing the vertex that it should root it on, and then it just does the rest because, well, there's no actual choice. Yeah, that doesn't look so bad either, actually. This looks like a little tangled mess right now, and if we go and play... Yeah, that's pretty sweet, actually. I like that as well. What do you think, chat? Spiderweb of a very drunk spider? Yeah, true. Look and feel without the little vertices is actually also pretty nice. So more balanced tree only if I change the class of trees, or if I did some additional work and trying to figure out where a good vertex to relocate on would be. Looks very organic. Yeah, that's what trees are. Trees are. They do model these sort of branch things that you have. Yeah. So actually this makes me pretty happy. It's pretty cool. What else can we do? More? What? I mean, I think I could go for more. How long did this render? Ah, the Opengl Renderer. Yo, Spooky-Koda. It looks like an enterprise software object hierarchy. You don't even have to go enterprise, just look at Manim software hierarchy. Do you know these diagrams that we have in our documentation? Reference manual. I mean, there you go. And this one is particularly great. The object one. So yeah, didn't have to go enterprise even. No, we close this. This makes me depressed. Go away. Okay. So, large tree, GG. Even larger tree. Let's test where the limits are. I'm curious. Stream should not start lagging. That would be bad. I don't think it would take that many resources though. So 500, I think 1000 should be possible with the Cairo renderer as well, even though it might take a little while. So what's the number of iterations that we can do per second still? Something must be like an enormous bottleneck for Manim at some point, and it would be interesting to identify what exactly stops it from working well with like large structures. I mean, that's still okay, like one iteration per second, 1.1. Manim calculations multi-threaded? No, of course not. Of course not. How could they be? Someone would have to implement that. No, but actually it's not that easy to implement multi-threaded computations because the frames are kinda dependent on each other. Or at least later frames always depend on the frames before that. Okay, I mean this looks already pretty nice. Let's see how the tree version of that looks. Ooh, it's a nice one. Yeah, that's pretty sweet. These curves, there actually are no curves. It's just, oh, I mean, this here looks like curves indeed, but just because, well, I'm actually not sure. I mean, there's some sort of iterative computations going on with the spring layout, so that the vertices, I think, how does it exactly work? You have the vertices, I think, mass points that repulse each other. So whenever two vertices are close, they try to push each other apart, and the edges in between act as springs that pull them back together. Basically, that's the well, what's the name of this tree? It's some random tree of size 1000. So no particular name. Yeah, the one thing I'm kind of sad about is that Manim didn't stretch this further, so that Manim decided that. I know why, because we've said that we told the layout the layout scale to be 4, which means that the tree should fit in a 4x4 box, and 4x4 means almost 4x4. 4x4 means that it almost fits in, or that it fits completely into the vertical space, but not necessarily into the full horizontal space. And this is one occasion where the tree is broader than high, which means that it actually hits the left and the right limit of the bounding box, instead of the one up and down. I think we can actually do something about that. Doesn't layout scale also accept like 2 parameters? If you say 3.9 and what's the other one? It's 16 to 9. And it's actually not 9, but it's 8, which means that this is 4 is the second argument. And the first argument should be not 16, like 15 half, like let's put 7.5. I don't know numbers. Let's render again. Show some pretty animations again. Okay, that actually didn't work. So I didn't implement the layout scale 2 for everything, it seems. Sad. It's actually sad. Well, then we don't have another choice. We have to specify 4. Something like 4 at least. Look at it again. Could maybe rescale if the trees. Could actually look at the height of the tree and then make sure that could actually use a moving camera scene and then zoom in or something like that. It would work, technically. But I think I'm too lazy for that. We'll just play around some more with these trees. And then I'll at some point, I'll actually do what I wanted to do and start working on the animation that I wanted to have. So give us something great. That looks sweet. I like the spring layout already. I mean, like looks a bit messy. And then we rescale and swoop. And now we hit a tree that actually is higher than wide. That happens. It happens. Sweet. Still pretty sweet. What do you think, chat? What do you think? Pretty cool. Yeah, one thing that would be fun is having a sort of animation that runs from top to bottom of the tree. Works in both versions. Yo. All right, so that's large random trees for you. There you go. Something that would be interesting to look at. Yeah, I mean, I want to do some... Ultimately, so what I want to have, and I could maybe start talking about it a little bit. What I want to have is... I want to have a tree, no surprise, where the edges and vertices in the beginning are faded out, or at least only semi-visible. And then what should happen is, one after the other, one of the vertices fades in, and with it all connections, all edges to further already faded in vertices. That's what should happen in a tree. And besides, I want to have some sort of scatter plot that shows how the number of uncovered edges develops while this process runs. And then we will see nice things. So that's the sort of thing I'm aiming for. On the one hand, the tree that uncovers step by step, and on the other hand, this graph that should slowly develop and show more and more data points, basically. That's the idea that I wanna realize. So what I'll do for that is I'll actually, let's check. So it was like 1 iteration per second now. What happens if I change to like 2000 vertices? I'm not afraid of big numbers. Python maybe is. No, actually Python is also not afraid of big numbers. Manim is certainly afraid of big numbers though. Aha, now it gives like 1.5 seconds per iteration. Python actually has arbitrarily large sized integers. Yeah, in principle, yes. Arbitrary, from a mathematician's point of view, is of course not entirely true because, well, there are integers large enough to require more memory than you have on your machine, obviously. Yo, they still rendered nicely, actually. This gets pretty dense, this situation here, actually. You can kind of see that the more edges you add, the more the spring layout is pressed into a circle, which kind of makes sense because I think this has something to do with sort of energy optimization and the shape that it will get drawn to. If we add more and more vertices, will always be like some sort of very dense ball in the middle, and then all the vertices are kind of pressed outwards, like this here. The edges going out there. Yep. So let's see. Sweet. One very deep subtree and the others not so much. That's a very frequent pattern, and actually this is something that you can also describe mathematically. So the shape of these random trees is actually pretty well understood from a mathematician's point of view. It will always look more or less like that. We know a lot about these. It's pretty cool. I did like my master's thesis and parts of my PhD thesis about these kind of properties of trees. We have some practical usages. I mean, you can use trees to model all sorts of things, river networks, all kinds of data storage structures. Like files, there are some file systems that are basically built more or less closely to trees. There's like B3FS that comes to mind. And yeah, understanding more about these trees then also means understanding more about the properties of the structures, basically, of your data structures, and how memory efficient they are, how efficient searching is in them, and all these sort of considerations. That's actually the sort of math I do for a living in my academic life. Yo, but this is I love this animation. I have to say I love how these just float to the right position. Even NTFS uses trees. I mean, all sort of file system use trees in some capacity, because as soon as you arrive on the topmost layer, in the sense of how the user sees the file system, you always have some sort of tree structure in the or file-based file systems, yeah. Non-file-based file systems. Oh, but yeah, you're definitely right. Okay, I really dig these. They're pretty cool. Some of the Linux drive for file system that uses SQLite. Of course. Why wouldn't that exist? One particular fun thing is that I like in this animation is that you can actually see how some of these structures are really elongated if you look at them here. So if you look at this part in particular here, what happens to it when I animate it into the tree form? It just gets drawn up. It's this part here. Up, and then it's just this little tiny part here, which is which was this part from before. So I think this is pretty cool to be able to look at how these structures behave locally if you make some changes, stuff. Yeah, and for that, Manim is actually a pretty good tool, because I mean, how many lines of code was this? Like, I mean, if you don't care about this sort of stuff and are happy with a less visually pleasing animation, it's like 5 lines of code. Pretty cool. So I did want to check how long did this render now. Like, must have been a little bit over 30 seconds, because it was maybe 40 seconds, something like that. So let's check what happens if we use the Opengl renderer instead. Where's my lovely window? There it is. Go, render. If the stream crashes, then it was the animation. Ooh. Ah. About the same speed, actually. Stream about to go down. I hope not. Ah, yeah, but you can see some. There are definitely some OpenGL specific artifacts that happen there, because this sort of disconnecting lines, also this didn't happen for the Cairo render. Yeah, there's still some work to be done. Sweet. I wonder whether it's actually the caching that took so long right now. Let's see what it does without caching. Because Manim does some fancy stuff. I assume it takes a little bit of time to generate, but not the tree shouldn't actually generate that take that long. Ah, there we go. I have no idea why the window jumps. Also kind of weird behavior. And otherwise the animation takes, I think, similarly long. like 30 seconds to render. A bit more even. I have to say I kind of like the Cairo animation more. I mean, of course, this is not a fluid video, and we should, in all fairness, actually look at the rendered video output and not the live preview, but still. We could actually try that and see whether the preview takes a lot of time here. I actually don't know. Write to movie. Let's go. How long does this take? I would assume similarly long though. It's a good question. Yeah, actually, it's actually slower. That's weird. I didn't expect that. I mean, maybe just because I don't have a good explanation why it'd be that much slower. But anyhow, so like 2000 vertices still works for the example. That's good to know. I might need a large example actually. But yeah, that's for later. That's for later. For now, let's go back to like 50 vertices. Now this would look kind of weird again. Higher renderer, preview. Let's go. 50 vertices should be fast. Yeah. GG. Can you show the video? Not anymore. It's gone. Just overwrote it. Okay, so we have a small tree. Still sweet. I can render it again if you want. Small-ish tree. Actually, we should also decrease the layout scale a little bit again. Let's go for 3.95. No, let's 3.9 should be okay. Get a large tree again. And then let's start thinking about how the uncovering could work. There we go. Sweet. I love this sort of animation actually. So satisfying. Take the thing, turn it into a tree. The vertex choice is kinda unlucky right now. If it would choose like one of these vertices down here, it would look more satisfying. But well, that's life. That's life. Okay, so back to what I originally wanted to have. 0.05, I think, something like that. So small vertices maybe. Yeah, should be fine. And we actually should try to get a tree that looks a little nicer. We can see whether we can make that work. And we will have to, what did I do here? We will also turn it back into the tree layout immediately. So layout equals tree, root vertex equals 0. Okay, back to no animation. There we go. Right. So what I want now is we could simply set the opacity of the entire tree to something slightly smaller. and then try to fade in stuff one after the other. The problem I see with that is if the opacity is low, then you will probably also see the problematic stuff that we did with the edges currently, because at the moment the edges of the tree meet at the center of the vertex, and if we tune down the opacity of everything, you will actually see the edges going inside of the vertex, which is probably visually not that pleasing. Let's see how it looks like. T.set opacity. Maybe let's animate it so that we have a comparison. Set opacity 2.1 and then self play t animate set opacity equals 1. Actually, I should write this with the set method as well. Let's see. Okay. Why is it full opacity? Okay, didn't... Wait. Something change? Not really. I mean... maybe very faintly, so probably we have to set stroke opacity. And maybe also fill opacity separately. I have no idea. We'll see. Okay, that doesn't look like it's opaque. No, okay. Was worth a try. Maybe set opacity works better. We'll see. If not, then we actually have a bug, I think. Already. Try to do something for 3 minutes. Please, no bug. Okay. Yeah, and there you can see. There you can see these unpleasant trees. Wherever the edges actually go inside of the vertices. Okay, and then this would be the fade-in effect. I mean, doesn't matter too much. We can emulate. We can emulate the opacity stuff by, well, coloring the vertices. So what I would do is I would set the color of everything to something that's closer to black. Let's go like, I don't know, 777. No, maybe not 777. 333 maybe. And then we set the color to white. Okay, there we go. Yeah, that looks better. And then it also looks like the tree fades in, but in reality we just changed the color. All right. So initially we can have this sort of faded out tree, and what I would like to do now is one after the other fade in the vertices. So vertex 1 should fade in, then 2, then 3, then 4, and so on and so forth. That's what I would like to do next. And then we'll... That should actually be not too hard, because I can just do something like this. Instead of setting the color of the entire tree, we can go and play an animation group which consists of the start list that runs t of some vertex v for v in t.vertices dot animate dot set color white. That's the animation group. Lag ratio equals 0.75. Animation group. Lag ratio. That looks okay-ish. We could probably set the runtime of the animation group to something fancier. Oh wait, the lag ratio should actually be inside of the animation group. Runtime equals like 3 seconds or so, and then we can see how well it works. Give me. So if we did this correctly, then the vertices should now light up one after the other. GG. So first step of my Christmas light animation is done. This works. What doesn't work now is, and that's the thing that we'll probably need to work on a little. What I'd like to have is, so this is like vertex 0 that you can see on top here, and then this is 1 probably, and then this here is 2, still no edges uncovered. 3, 4, 5, 6, 7, 8, 9. And here would be the first edge that should be uncovered. So as soon as this light here goes on, the corresponding edge should also uncover. So yeah, that's the next step that we need to do. The question is, how do we do that? Can we make it so that these edges fade in simultaneously with the vertices? Probably yes, but it might require some work. Maybe it's not that complicated even. I mean, what do we need to do? We just need to check. All edges that are incident to the current vertex that we are uncovering. And we know the current vertex that we are uncovering. And I think Network X can help us to determine all of the neighboring vertices, and to all of those where we have an edge, these edges should just be in the corresponding animation group. I think we can do it. The animation group might be a bit, probably write it and then never touch it again, but it should work, theoretically. Let's see. I need to try something first. Namely, I need to check how exactly Network X allows me to access the neighbors of a vertex. So, Python. Actually, we have a Python running still here. And G is the thing. So we can go g.neighbors of vertex 7, which is a dict key iterator. How does that look like? G has a list of neighbors, and in this case, we actually know everything. I mean, it's not that hard even. Because now we can filter out all of the vertices where in this list that have a lower index than G itself. So what would I need to do? This list here needs to be more complicated. It's still, I think we can still write it in list comprehension actually. We iterate over all vertices in our graph. Then the thing that has to be returned is again an animation group consisting of the vertex is faded in anyways. And then optionally, there might be a second list of things that get added to this animation group. This can be closed here immediately. And this is, what is this? We have to go the edges of our graph T with a pair VW, animate set color FFF, for W in an xtree.neighbors of V if, can I just say if V is less than W? No, other way around. If W is less than V. Maybe that works already. We just try. Oops. Close this one. Do it. Key error. Oh, I can't do. That's bad. I mean, obviously. So either VW or WV is in the is the edge. That's bad. Do I have a get edge or something like that? That's not the right thing. Yeah, that's annoying. That's actually annoying because now we need to check somewhere here whether VV or WV is in the thing. And then this means we might have to actually... Oh, that's so annoying. I can't even do much. We would need to change the data structure of the trees, and I don't want to modify the library for that. Is it maybe always VW? Maybe we are lucky. Maybe we are lucky. Imagine chat being lucky. Actually lucky. Yo, but does it work? Nodes uncovering, nodes uncovering, nodes un... Yep. This one up here faded in, and with it, both of the edges. Yeah, it does exactly what I wanted to. Lovely. Sweet. And in the end, everything is there. Yeah, that's pretty cool. I love it. Let me actually make the layout scale a little bit smaller so that it fits onto the screen a bit better. 3.5 is enough, I guess. I did not think that we would be so lucky, actually. It works first try, more or less. Yeah, I'm never touching this part here again, actually. Sweet. Very sweet. Okay, two things I'm interested in now. A, how does it look if the tree is larger, like substantially larger? Instead of 50, let's take like 250 vertices. Like this. Rendering a little bit slower, but it should still work actually. I didn't realize that we had sorted the edges, the edge tuples. I mean, that's really convenient actually. Okay, the nodes have to be a little bit smaller again, but that. Yeah, the vertices, the nodes have to be a lot smaller. The effect isn't that as present. Let's try to halve the size and see how it looks then. Could have just skipped to the end and looked at it. Well, anyhow, we're doing it. And then I probably have to increase the runtime of this uncovering, because otherwise it also doesn't seem so interesting. Yeah, you get a better feeling for the structures actually. I think that's good. There are some vertices that don't seem to be fully uncovered, but I think that's because there is a missing weight. Missing weight here, and then let's actually increase this runtime to like 5 seconds, because a lot of vertices, it should have a little bit more time to uncover them. Okay, here we go. Large-ish tree, uncovering. That's nice. There's this nice effect, and I've actually recently worked about that a little bit. There's this nice effect. For the longest time, you have only very isolated clumps, like here a little bit, here, over here. And then this is going on for a long time. So still very isolated little structures. And at some point they start connecting. And then close to the end of the uncover step, which is like here or so, you suddenly have a lot of edges uncovered, which is nice. And there you go. Whole thing is uncovered. 5 followers again. Oh, you are fast with the pen hammer. Yo, look at that chat. What's up with the bots today? I have sometimes it is like that, but it's kind of rare that there are so many. It's kind of rare that there are so many. Ham banner. Isn't there a hammer emote usually? No epilepsy warning. True. Okay. So the next step I'm interested. Oh, it looks so satisfying when the whole tree suddenly emerges. I like it. Okay. Next point of order. I need a tracker. Penhammer mode? I thought wasn't it like a global one? Or maybe not. This one, Pop. It's even friendly. Anyhow, so next step, I want a counter. And that might be interesting. Counter might be interesting to get. Actually, It's just a value tracker probably. Some updater maybe. I could use the same animation group to do more things in it even. Even more things in the same animation group. You know what? Let's try to do one thing first. I kind of want to first compute these numbers actually, because we need to consult network X again with how exactly we can get them. And then I need to think about dimensions of the graph and stuff. So actually not that difficult. Because I mean, what do we know? At some point I should let's use capital N equals 250, and then this is capital N here. So now we need these numbers, uncover numbers equals. So what I can do is I can ask network X to consider the induced subgraph and then count the edges in that. That should work actually. So T dot subgraph, NX graph, NX3 dot sub induced. Oh no, we have a problem. Why doesn't it have a subgraph thingy? Doesn't it know? It probably has, but it doesn't know. G dot subgraph. Yeah, it does know. Range 10. SG equals this guy. SG list SG dot vertices nodes. And the number of edges. Len SG edges. 7 edges, and that is good actually, so it means it works. So I can just go len of an x3 dot subgraph of range of v dot edges or v in range capital N plus 1. And now I want to plot these. Manim has a scatter plot thingy, right? There's something that I remember. But otherwise, we're probably better in coding lots of stuff ourselves. X equals x's. The x range of these now has to go from range equals from 0 to n, because that's the number of vertices we uncover. The y range always has to go from 0 to n minus 1, because n minus 1 is the maximum number of edges that we can uncover. Plot, what can we plot? Line graph. That's good. X values, Y values. That's actually pretty convenient as well. Range n plus 1 plus, and the second argument is the uncover numbers. And now let's add let's just add it and look at it. X line plot. I mean, I have no idea how this actually will look like. Yeah, making way more progress than I thought. That looks actually pretty good, mostly. We definitely have to get rid of the ticks, and the sizes of these dots are ridiculously large, but other than that, this is pretty much how this should look like. So the stroke, the ticks have to be improved, let's say. We could already scale it. I could already scale it. Should I? Then it would be in the interval 0, 1. I still don't have a good way of uncovering this though, so maybe not. Maybe not. I mean... Okay, I think I'll have to investigate how line graph exactly works. And then if we could like have this sort of graph somewhere here in the corner, and then while this tree uncovers, this gets drawn, this would be amazing. Then I'm actually already happy, more or less. I mean, there are some more animations that I want to do with the graph then, so that's why I'm thinking of just writing that on my own. But yeah. So my hope with the axis would be that I can just say like x ticks, x axis config, I could also probably just set the step size to something ridiculously large. And then we shouldn't get any ticks, maybe. Let's see. Yo, this actually works surprisingly well, I have to admit. I did not expect this to work this well. Aha, got rid of the ticks already. Easy. Okay, now we need to find a way to make this pretty. And then we scale this bad boy and move it to the corner. Actually, we can also just probably move the tree a bit left, and then I should at some point also decide on some fixed random tree. Because we can't really have a... If I want to use the space optimally, then I kind of need to know the dimensions of the tree. And if the tree is actually random, then it could happen that... that it's too wide. We can't have that. This cannot happen. Okay, let's look actually into the documentation because I have no idea how the thing works. Docs. Reference manual. Objects. Graphing. Coordinate systems. Axis. Plot line graph. So what can we do? We can set the line color. We can set the vertex dot style. That's exactly what I want. Axis plot, line graph, this one. So this is where we pass the x and y values, and then we can go and pass the, what was it called? Vertex dot radius. Really? Can just set it to 0 because I think I don't actually need it. Ah, comma. Can you just determine the area of the tree to set the width? I could ensure that the tree doesn't get too wide, that's true. But I think it would still look prettier if I had some specific random tree in mind, then just worked with that. Okay, so that looks already good. Now we need to scale this guy and manage to uncover this graph slowly somehow. That will probably be a bit challenging. Might take us like 5 minutes. No, I have no idea actually. I have to look at the implementation of the line graph and whether we can easily modify that stuff. But for now, this looks pretty good. Pretty good. So let me... Can I also change the... what was it called? Stroke width. I mean, okay. To something like 2 or so. Let's see in what weird dimension this is measured. Do something. Hey, what's the time? Ah, okay, still have some time. Let me quickly check something, because I think I've been lazy again and did not do my Duolingo today. So I should at least make sure that I have a streak freeze. I have one, okay. All good. There we go. Much better again. Oops. Okay. So we have the tree, we have the little graph. Now let's scale this graph by like, I don't know, probably half. Maybe even more, like a factor of a third or something like that. And then we'll move it to the top right corner. And I'll move the tree as far left as I can. So let's move some stuff around. Self V group consisting of X and line plot, scale by 0.33. Just take a third. And then to corner, up plus right, and the tree, we'll move the tree set color dot to edge left. Okay, show me what we've done. Show me what we've done with the place. Okay, the next step will then be we have to synchronize the uncovering of this line chart with the uncovering of the tree, but that should not be that difficult. That's not so bad, actually. Tree looks kind of weird. Maybe it's just a tree. Can actually make this larger again. And maybe not move it so far to the corner. I'm wondering whether moving this to the left corner did something with the alignment. I thought it would only move the entire thing. Well, we'll see. We'll see in the next iteration. So 1/3 is maybe too much. Let's take like a half. I could, for this particular exercise, also actually skip rendering the animation and just display the last frame. Would probably be faster. So we're not that interested in the animation right now. Let's maybe do that. I'll think about it. I'll think about it. Yo, there we go. I have to say, I'm actually pretty happy about this. Did not expect this would turn out so well. Okay, let's couple the animations and the uncovering of this bad boy over there. So, what do we have to do? I should wait. Actually, I should probably set the rate function of this animation to linear. Now that I think of it. I mean, it's probably not so easy to see, but well, should be fine. Okay, and now there's a second animation we need to play in parallel to that. And this one should take care of uncovering the line graph from left to right. So we should check out what this line plot actually is and what this plot line graph actually returns. Let's look at the function. What does it return? Line graph is what? Add vertex docs. Actually, we can disable that. That's neat. Let's do that immediately. Then I don't have to set the radius to 0. Wait, what? Where was it? Add vertex dots. Where are you? There. Add vertex dots equals false. Should have read the documentation of the whole thing maybe before I just YOLO'd. Okay. So these are the vertices, and then the line graph is this bad boy. Line graph is VDict. That's interesting. And it's actually just a... Oh, it's really a line. Well, that makes it difficult. That makes it difficult to do the right thing, actually. That actually makes it kinda difficult to do the right thing. So we should maybe still do our own thing. I mean, I can do like a... I could do like some sort of piecewise become partial and then feed in the points, but the problem is... Okay, I think we'll have to look at this in and inspect closer. It's the same old problem. It's the same old problem that people usually have when they want to do like stuff with polygons, and then they can't get a singular side of the tree. Maybe replace the line of the line graph by some connected dots, uncover at the same time with the tree. Yeah, that's ultimately, that might be what I have to do. I'm tempted because that I know would work. It's kinda, it might be, maybe it's a bit of a challenge to get this thing working. So I'll spend some time on this, and if it doesn't work, then we'll just leave it as is. And actually, I mean, if this is really just a... The problem is that the line segments are different, are of different length. So if I could right now already, I could show you something. So we could definitely go and do something like this. Animation group ends here. So this would be next animation. So we could say right, maybe. Actually, create is fine. Create line graph. Line plot. Runtime equals 5, and same rate function. Linear. If we render this now, then it should look like it matches more or less. It might be good enough for now. But with this thing looking like it does, it might be difficult to actually do something. Because I need to transform this curve a little. And that could be complicated. So see if I look at this now. I mean, it's pretty cool actually. The problem is you have no, I mean, it's hard to see whether this would actually match. But if we look at singular frames, like here, it might actually be true that this is the correct distance that it jumps. And also over here, right? There are like two edges that are being added, and this looks like a small-ish increment. Maybe let's look in the beginning again, where there's more. Where nothing happens. Nothing, and here two edges. Actually, I think this is the accurate. So maybe we don't have to do anything, which is kind of nice. So we have our tree. We have our graph, which does already the correct thing without me doing anything. And now we could investigate either how that looks if we make it larger again, or I could show you more interesting stuff about this. So ultimately what I will do over here is there's a function that we can subtract, some sort of mean, if you will, and then we look at the difference that remains. And this thing will look funny, basically. I'm actually, I have to say, kinda happy about this. We could simultaneously do a second graph. We could do a second graph that describes the number of connected components. That's actually also a fun thing, because you will see that the number of connected components in the beginning, when there's nothing uncovered, is 0. Then it is 1, and then it rises up rather quickly until in the end it starts to decrease again, because the things get connected together, and the number of disjointed pieces decreases again. This is also something that we could do. Let me think how hard it would be. Not too hard, actually. It would work pretty similar. We also need a new axis. We could move them into the bottom right corner. And we could create the graph in a pretty much similar way. Let's do it. Let's do it. I want to see it. Mainly because I want to see it. But then let's rename stuff a little bit. So the line plot is then bad and should be renamed. I can do this in a nice way here somewhere, right? Refactor. No refactorings available. All right. And we don't. This is the edge uncover plot. Edge uncover plot. Edge uncover plot. I could have done the global search and replace. Edge uncover plot. There we go. And now let's add a second axis. I mean, this is a bit ugly right now, but nobody's looking, right? Don't forget lettering the XY axis if you add a new graph. So these are sort of things that I have to do separately anyways. So I'll have to check that anyways a bit later though. There we go. So we need the component numbers, and I hope that this should be easy again. nx3.subgraph range of v dot connect num. Ooh. Wait, but I think it does know these sort of things. sg.connect number of edges and number of nodes. That would have been a thing. Okay, good to know. I can compute them if I really need to, but I would rather not actually. Why doesn't it know? Edges, adjacency, clear, degree, frozen, graph is directed, name, neighbors, nodes, order, subgraph, update, remove. I'm sure you can check the number of connected components with NX, network X. Let me quickly check something. I'll need to read documentation. Network X number of connected components. There we go. Number connected components. Wait, what? How does it work? Directly an X. I see. So it's an X.number connected components of the graph. Okay, I can live with that. So it's an X.number connected components of my subgraph. Or v in range n+1. So these are my new numbers. And now we go and add a new axis. X range, actually the same. Can we just make a copy? I think we can. x2 equals x.copy, x2.move to corner, down plus right. x2 dot, so this is now the component number plot equals x2 dot plot line graph, same parameters as above. Go away, documentation. I don't need you right now. Copy, paste, and this we replace with the component numbers. And then what? Actually, we shouldn't have added that one. X and x2. There we go. And then we create another one of these. Namely the component number plot. Yo, I'm excited. I'm excited. This should be like this this fun little shape like that. Yo, hey AppGear. We're doing fun animations today. How's it going? I'm doing pretty good. I'm progressing much faster than I anticipated actually. I thought this would take the entire stream, but right now we're flying through the animations. Yo, so here's my uncovered here's my covered tree. And now we start uncovering the nodes. You can see the number of connected component rises. And the number of edges is still close to 0. Rises further, rises further, rises further. And then at some point this goes just down again. Sweet! It's fun to have visualizations for that stuff. The Y range can be adjusted though. What's the maximum number of connected components that you can have? Probably half. What's the maximum number of connected components that you can actually have? No, you can have up to n. It's when you have a star and you uncover the central vertex at the top at the very end. I mean, I find this satisfying. I don't know about you guys. Sweet. Okay. Okay, that's pretty cool. I like that. What do we do now? I could move on to the second part of the animation actually. Could you run it again for a different tree? It's always a different tree. So whenever I run it, it chooses a new random tree. Let's run it again. New tree, new graphs. Oh, this one is fancy. Lots of stuff gets connected here. Look at that. Huge jump. Ah, because of this structure over here and this structure over here are getting uncovered simultaneously. It dries pretty quickly here. And you can also see the number of connected components drop because so many things get connected at once. So you can see that this here, first the one and then the second one, you reduce the number of connected components quite a bit. Another graph for the number of clumps. I mean, the lower one is the number of clumps, and the upper one is the number of uncovered connections. So that's exactly what these two are. And the stuff I've been working on recently with colleagues, I was making pizza last. Ooh, pizza. Lovely. Yeah, so the lower graph shows the number of clumps of different unconnected structures, and the upper one is the number of uncovered connections. And in the end, it looks like that. Pork tasty. Lovely. It's kind of disturbing. Yeah, only if you look at it closely. We only have good emotes here. This channel only has good emotes. Yo, I wanted to check recently how much longer I have to stream until my follower emotes are unlocked, because I think it would be nice to move basically all of my emotes to follow emotes. Then you don't need to subscribe and can still spam the weird mark thing. I think that's definitely worth it. Anyhow. You can also join my Discord. You can spam the emotes there for free. So this is kinda sweet. I really like this. And I did not expect that this would be so easy to make. So what I want to do now is, what do I want to do now? I could show you guys something else in connection with these funny little lines. So basically the next part of the animation would be fade out this guy and probably also the tree again, or maybe you can move the tree into the background somehow. Beans emote next. The thing is that, I mean, I'm bad at drawing, you know that. So I took this beans emote from the current proposal. They should actually be added as an emote to like the, maybe they already have been. Let me check. No, I don't have a beans emote yet on my device. But they are in the standard of the Unicode emoji thingy. So in at some point over the next at some point you will all have these little beans as an emote, because I took it from their website. I took it from their website simply. Yo, so that's fun. So next steps. Next steps is probably moving this into the background some, or maybe just making this a bit larger. Fading this out, making this larger. Drawing the line that actually is supposed to be there. So the stuff that you would get if you would run this line for lots of different random trees. you'll get the sort of smooth mean line, which is actually just a scaled square function, a scaled parabola. And then once you have that, once you have that, it will be, I want to subtract the other line. So the aim is, you are doing an emote that I can't see, and my chat can't render either. So that might be it actually. It's too early. You're an early adopter. That's the bean, yeah, I suppose. I guess it was. So technically you have the bean already, see? Yeah, but I could actually add the beans emote just as a normal thing as well. I'm not really creative with my emotes, I have to admit. I have no idea what I should add. So suggestions are welcome. If anyone has an idea. I have you can either say just here, or if you come up at it late at night, wake up and then think, well, this would be the perfect emote for Benjamin's chat, and just post in my Discord. But I do hope nobody wakes up in the middle of the night with thoughts like that. Okay, so we continue. I wanna wait, then play, fade out, off. The second one, x2, and can I do multiple ones? Yeah, I can. And the component number plot. I could add the Manim icons in the mode. Actually, I could. That would be a nice idea. Why didn't I think of that yet? I mean, I have limited emote slots. That's probably why I didn't do it yet. Kind of wanted to have more personalized ones before I take over Manim. Manim's CI in my stream. But having one would be nice. So x2 component number plot. And we can fade it out in a certain direction. Shift down. I like to do that because I think it looks fancy. So, and if it's not broken, we can also skip the part where it renders the tree. Minus n1, something like that. Does it work? It does. You can actually also get rid of the weight. And I would like to play the other animations also simultaneously, I think. So I'm thinking of moving the tree in the background sort of and making this larger. So I'm thinking of doing something like this. T dot scale, maybe just center, T dot animate center, and maybe scale by a factor of 2. It doesn't matter if it doesn't fit exactly on screen anymore. And we set the color again to something much darker. 333. And I don't need a thing, it's fine. So then the tree is in the background again, and then we want to move the graph in the foreground. So we should take the graph, which is at this point a V group of X and what did I call it? Uncover plot, edge uncover plot. Animate center. and scale by a factor of 2 as well. Okay, this will probably look terrible. Let's see. Let's see it. I'm moving the tree, that's why it takes so long. Large things take long. Okay, large tree this time, I see. This moves down, this moves up, and this is in sort of the background. I'm okay with this, but I would like to have a prettier tree. Maybe the tree should be even larger. It's not so bad actually. Kinda like it. And we can actually also render from the second animation on. Let's try again and try to get a nicer tree. I should really set the random seed at some point to something I like. White tree. Yeah, I rather wanna... This one, perfect. See? This is what I like. Yeah, sweet. That's exactly the effect I was going for. Is the tree in the foreground or in the background? It's in the background, even better. I think it could be even less present, so we should set the color to something even darker. Let's go for 222. White tree happy. I should make an emote like that. Yes. You can submit like custom 7TV emotes, right? It's possible. Yo, look at this. This looks sick. I like it. Okay, I mean I'm pretty fine with this actually. This looks great. Next up we will have to draw the graph of the line that I want to subtract. So let's add a self.weight, and then we add a self.play. No, actually we create the graph first. And this will take some guessing now, because I mean actually I do know the exact formula. Can I do it unparameterized? Yeah, I think I can. It should be fine. Capital N was the thing, right? Yeah, should be fine. Okay, let's go. I can do this. We can do this. Can we really? Yeah, sure we can. X.plot. So this is the mean curve. Not because it is mean, but it's because it's the mean of something. And we plot lambda. Trollkirsche added the emote people pork climbing tree hard for house. The sibling of... yeah, that one. Let me reload the chat plugin, then you can probably see it on stream as well. This one. Refresh. Should work now, maybe. No, it doesn't. Maybe it takes a bit more convincing. Sorry, guys. Let's go back here. Lambda. T. So, and now we need to think. I know that it's pretty much like e squared, but we need to scale it correctly. And actually, we could use the exact thing. Wait. I could look it up, but let's just use t squared and scale it by n-1. Should work as well. More or less. Let's look at it. T squared divided by capital N plus 1, n-1. And this for x range, we don't specify because it should just take the correct one. And the color should be red. Self.play, create mean curve. And we wait afterwards. Show us. If we did this right, then this should be a curve that's pretty close in almost all points to the yellow one that we had already. We'll see. Exciting. Okay, so that's our tree. Wait, larger, waiting. Yeah, that actually doesn't seem so bad. And now, what I would like to do is normalize. Or not normalize. I would like to... Actually, we should make sure that we use the same stroke width for the red line as for the yellow one. And then I would... Some sort of animation that subtracts the red line from the yellow one. So the graph that should result should be something that's pretty close around the origin. That's what I want to have. Something that lingers around the origin a little bit. And then we'll see. And then we'll see. Yeah, actually, I'm pretty happy about this. This looks pretty awesome. The one thing that's probably not entirely correct is the formula for the red line. And that might be a problem. Because in the end, what's the last line? What's the last value that I plug in? The last value that I plug in is n. So it should, and then it should be at n-1. Animating a next up, animate a body graph for an active RC network just for those. No, thank you. No, thank you. I'm not a network guy. I just look at trees and do pretty pictures. That's my kind of stuff. Okay, but this makes me happy. I'm pretty happy about this. So next step, making this line as thick as the other and then subtracting. Yo. Where do we... Here probably. What's the stroke width of the other one? Like 2? 2. 2 underscore question mark. Stroke width equals 2. That should have fixed it. But the formula is not entirely correct because, wait, what do I want? If I plug in n, I need to get n minus 1, and that's not correct right now. So what I actually need is this divided by n squared. Yeah. That's why I got confused. This divided by n squared and then times n minus 1. This is the correct one. Yeah, much better. Let's look at the graph again. If we did this right, then the red line should actually end exactly where the yellow line ends as well. Yo, there we go. Okay. Nice. Yeah, exactly. This is exactly what I wanted to have. The red line now ends exactly at the point where the yellow line ends. The starting point is correct because when we plug in 0, we get 0, and the end point fits as well. And now we might actually see some fun stuff happening when we subtract these two. Especially when we make the trees larger, then interesting effects should happen. And right now the fun thing is I can scale this however I want. I can just plug in like a small number. Let's actually render the whole thing for a small number. Then we will probably see that doesn't look as impressive. So if we take a graph with like 50 vertices, it's not as large. And the graphs will probably look a little bit more janky. More edges and stuff. Why am I almost out of the... because I played Dead Cells last, I remember. Move myself a little bit inside more. Okay, so there we go. Ultimate check whether this actually works, what we did. We begin, trees on the left. So there's one vertex, the line is about 1, 2 vertices, 3, 4... Still continues to grow. There's the first line happening here. So this here starts moving up, and this one should stay horizontal. More. Exactly. Line moves down again, and this one reaches the top point here. This one moves up. We get our line. Beginning and end match perfectly, and that's it for now. Sweet, pretty sweet. Looks exactly like I want it to. So this is for like a smaller graph, and now we should also try a larger one. Maybe wait a little while. So let's try like 500 vertices. It's like twice the amount of vertices we had before. Twice the amount of nodes that we had before. I'm excited. Yeah, but I mean for like, what do we have? 60 lines of code? This is pretty nice. This is a pretty nice animation for like 60 lines of code. Could be much worse. I think we did a pretty good job with this one here. It's actually a pretty compact way of doing what I thought would be difficult initially, but actually just need to do the correct things. Much slower than expected. Yeah, much smaller. Okay, there we go. Larger tree. We should see the same shapes of curves again. So this one again should grow like a parabola up here, and this one should look like this, and the tree should line up appropriately. Let's see. Yeah, exactly. Lovely. The cool thing is now with more vertices, the more vertices we use, the closer this curve here will get to the mean curve that I mentioned earlier. If we take a random tree, if you take specific tree shapes, then these two curves can be pretty degenerate as well. Can maybe show an example later. Okay, so this fades in, and then we have the curve which fits pretty nicely. Sweet. Okay, so we can do this. We can do this. Let's enjoy it. Full animation. I like it. I did not expect that we would get this far in like how long am I streaming? 2 hours? It's pretty cool. Okay, so the next issue that we have to deal with is rescaling the graph a little bit, and that might actually be tricky because I think the transforming the axis in a way that looks good might prove challenging, but I might be wrong. We could initially just plot the difference like right down here on this graph, and then we will see how it looks like, I guess. So I will take the yellow curve and subtract the red one from it. That's basically what I do. And how do we do that actually? How should the animation look like so that this is sort of visible that we take the difference here? I guess it would be kind of fun if the red curve morphed into like the straight line and the yellow curve moved with it. I think that would be kind of neat. I guess we can do that. That shouldn't be too difficult, right? Let me check. Maybe it's actually just a matter of playing a transform. I'll transform the red curve into a similar curve, but one that's basically on the horizontal. If the animation looks nice in the sense that the curve actually gets pushed onto the other one, then we can definitely do that. Otherwise, we might have to, well, figure something out. Let's go. So what I want to do is I create a normalized how's the mean curve? Normalized mean curve. which is x.plot lambda t 0. Color is red, stroke width equals 2. And then we play a simple transform between, actually I'll play a replacement transform. Replacement transform from the mean curve to the normalized mean. And then we'll wait. What's the number of this animation? Actually 6, so we can skip the first 5. Should be n5. We'll see, chat, we'll see. Rendering already takes quite a while, but I mean, I suppose that's obvious, given that it's more and more complicated. All right, so what's this? Yeah, that's exactly what I want. That's actually literally 100% animation that I want. It's exactly this moving down. And now if we manage to do the same thing, so I just need the second curve, this normalized version, I need that in a similar form. So I need to have the subtracted curve in a similar form as this yellow one, and then we can simply transform it, and it's easy. Let's go. I can increase to 6 actually, I just saw. So we need normalized. That's not the normalized mean now, that's the normalized, what did I call it? Uncover curve. And that's not a plot, but that's a line plot line graph. So how did this work? We specified the things and then we just set component numbers here, but we have to change that over here now. So we specify the same arguments, but instead of just using the uncover numbers, we have to enumerate for t value in enumerate. And now we do what? We take the value and we subtract this stuff. And that should be it. And then we play another transform in this one here, another replacement. From the mean curve, the edge uncover plot to the normalized uncover curve. So you see, I couldn't even stay consistent within these 70 lines of code in terms of the naming. Okay, let's go. Let's go. This is pretty exciting, actually. I'm curious how it will look like. And whether I did it correctly, actually. There we go. This is exactly what I wanted. This is pretty sweet, actually. So now this is like normalized, and we've removed the mean from it, and now we see only the fluctuation. And what we can do now is we can increase the scale. We can stretch this entire thing in the y direction. So, and then we should also rescale it probably. At some point I have to. This should actually, I'm sort of confused, slightly at least. This should be in a different magnitude. Maybe I'm misremembering things now, but actually these fluctuations should be about as large as square root of n. Which, to be fair, might be true in this case. Which, to be fair, might actually be the case. Because, I mean, what's our n now? 500. The square root of that would be how large? Yeah, that might not be too wrong actually. This might very well be in the square root magnitude. Sweet. Okay, so here's what, yeah, we want to see these, we want to zoom into that a little bit more. So what we'll do is we'll try to stretch this, which means I'll move the axis in the way that the x-axis is in the center, and then I'll see what happens if we just apply a regular stretch function to it. And scale it just just vertically. We'll see. We'll see. Yo, hey, Snoo Studios. Nice to see you. Welcome. Welcome, welcome. We're just doing fun little animation here today. I wanted to work on the library initially, but at some point I don't know, decided I'll do an animation of my own. It's been a while since I did that last. Yo, thanks for following. I appreciate that. Enjoy bean counting. So, what I want is we move the lower critical point to the center of the scene, which means that we have to play the V group consisting of all of these now. So the axis, the edge uncover plot, and the normalized uncover curve. We shift that by some amount that we still have to determine. Animate.shift. Animate.shift. We move it by... We want to move it the lower point to the origin, which means that we just take the negative. We just take the negative lower point. Minus x dot get edge center down. Maybe we'll see whether that works or not. All right, then it's in the middle, and then we do what? Then we stretch it. Same V group. Actually, I should probably name this. Plot group. to be even more inconsistent with everything. And then we can just say plot group, animate shift, and then we use the same plot group again over here and say dot stretch to fit height. Can I just say stretch? I don't like these. Factor, let's use a factor of at least 3 because we want to see these fluctuations, and the dimension is 1. 0 would be along the x-axis, we want to scale along the y-axis, so this is dimension equals 1. I think we will see whether it actually works. And we need to pass animate again. And then in the end, we wait. Show me your magic, Manim, show me. Show me how bad I can break things. Dum, bum, ba-dum. So how's chat doing today? For me it's already night, but I'm not sure where you guys are from. Cozy evening plans? I should maybe make some tea. How late is it? Oh, it's maybe a bit too late for a full. Ooh. Oh, I hit the replay button. I'm not mad about it though. Pretty good, just the old homework. Oh, I see. Homework stream. Yo, there we go. Let's see. So remember, what did we want? We want to have this thing in the middle of the screen and then have it rescaled so that we can see these fluctuations better. Let's go. Woo! What happened? Okay, why did this not move with the graph? And then what? Ah, it stretches the it stretches the axis about the center of the axis, I think, which is not helpful in this case because this means that it gets moved down again. So we should check whether there's some sort of about point that we can pass to stretch. Okay, and why this one didn't move, we'll have to see. Well, I can't win every time, right? You can't win every time. Edge uncover plot and normalized uncover curve. Yeah, I mean that doesn't work. It's the normalized mean curve. Okay, solve the first mystery. Second mystery, does stretch have an... Where is this even object, I think? Normally this is something you would look up in the documentation, but I'm just faster if I just look at the implementation. Stretch. Keyword arguments. Apply function about point. Yes, you can specify the about point. And I think it's actually called about point. Yeah, it is. Tree dim equals 1. About point equals origin. Origin. And we re-render and hope for the best. Hoping, still hoping. Manim is rendering. Yo, it's kind of exciting. Maybe it works, maybe it won't, who knows? Then again, I could just look at the last frame of the animation and we wouldn't have to sit through all of this all the time. Could maybe do that. Ah, but now we're waiting already. I don't change now. Show me your secret. There you go. Okay. Oh, didn't see anything, but it looked good actually. Moving up. Scaling. Yeah. I mean, why does it still look so weird and move up? Ah. Okay, the problem with the moving up while scaling is the following. When I say I want to move the axis so that the horizontal part lies on goes through the origin of the scene, I actually took the lowest edge of the axis or of this entire group here, and in this case this would be the point that the lower end goes through this point of the triangle of the axis here. So this is why this point here is stationary, because this is the one that actually exactly lies on the axis. So this just moves up. Big arrow. Should we also make a white arrow happy? I can make all the emotes white and happy. Yo, but what? This means that we have to do actually have to do a more careful shifting upwards, which is annoying. Which is kinda annoying because it means I have to think about stuff. Can I just? White arrow next white bean. Yeah, that doesn't even... Can make that in like 5 minutes. Okay, so the scaling is kinda annoying, I admit, but otherwise this works pretty well. How would I find the correct... How would I find the correct... I need to check whether the axes know some sort of origin, and if they do, I could take the y value of that and move it up by that. That would work probably. So we have to check whether the axes know their origin. From Manim import star axis. Get origin. What? Why are the axes at C? Because they are empty, and then actually it's true. Yeah, that works. That works. So I can use the y coordinate of the origin. That works. Yo, so this here was bullshit. Yo, thanks for following, Hubert. I appreciate it. So this here was simply bad, deleted. And instead we put in axis get origin the y coordinate 1 times up. The direction might be interesting now. We shift it by minus something, but the minus should be... So that might work. That might work. That might work. And here we actually maybe don't want to... We actually just want to stretch the normalized uncover curve. So if we take this and then go and render again, We render again. And then I kinda want to look at the whole thing. If this looks good now. I also think we can stretch it by a larger factor than 3. Exciting. Are you also excited, chat? Yo, there we go. Moving down, shifting up, scaling. Sweet! It looks better. And now, I want to see this for a large tree, like for a really large tree. So let's do the same thing, but let's use like 1,000 vertices this time. We'll render the entire animation for 1,000 vertices. I'll preemptively reduce the size of the vertices a little bit. Let's make it like 0.15, 0.015. And then we go up to 1,000 and look at the same thing again. Actually, let me scale this thing in the end by like a factor of 4 so that you can see it better. There we go. Actually, I want to render everything. Everything. Full animation, let's go. Yeah, this will take a while now. This will take a little while. Not too long though. So I don't think... How long will the rendering time take? I think it's a bad... That's a bad gamble. But it shouldn't take longer than like 5 minutes. That seems even a bit long. I mean, there are like 8 animations or something like that? And only the ones where the tree is involved take a long time, because only the tree has lots of objects. Everything else should be more or less smooth and fast. I don't think it would pay off to switch to a round of GeoGuessr or so though. Otherwise we could do that technically. I could also try fixing the random seed of NumPy. Then Manim might actually start reusing already rendered segments. It does have some sort of caching mechanism. The question always is whether Manim recognizes that something is constant or not. For this here, it might be difficult. But the tree layout actually is deterministic, so that wouldn't change. Maybe not. Animation 4 is done. 5 is done. Give me 6. That's the replacement transform. Isn't related to Manim, but I've just solved one of my DivGeo homework problems. GG, nice. Good job. Solving problems always is the nicest feeling. 7. That's 8 coming now. That should be almost done now. I think that's it already. That's the last one. And the weight. One weight after that, and then it's done. It's curious that these animations of these line graphs also take so long, but I suppose it's because they have so many points. Yo, look at that. Look at that tree. Look at that tree, though. It's a good one. I like it. Okay. Ready, chat? I'll actually go. Well, should be enough. Let's go. Play. Sweet. Red curve. Difference. Scale. Poke. Again. Yeah, that's pretty cool. Good stuff. It's rare that I... What does the top graph represent again? The top graph represents the number of uncovered edges in the graph. So basically what this does is it steps through the graph, it uncovers one vertex at a time, and whenever two adjacent vertices are uncovered, then the edge between them is also uncovered. And what happens now is it goes on and on and on and on, and as you can see, as more and more edges are uncovered, this thing here rises and rises until in the very end the whole tree is uncovered. And then you can actually check that this curve here behaves more or less like a rescaled parabola, and these fluctuations that's in basically in a paper that has been accepted today. We have characterized these fluctuations here. It turns out you can describe this very, very accurately, and describe how these things look like if you tend to infinity. What they are structurally, let's put it like that. Basically, they are rescaled. So in the limit, they are like rescaled Brownian motions, or related to rescaled Brownian motions. Would it be very difficult to make a rotating hologram out of the tree? What do you mean with rotating hologram? I can make the tree rotate, that would not be a problem. I could also make it rotate in like 3D so that it looks like it comes out of the plane. That would also not be very difficult. "3D in Manim scares me." Yeah, not me too. I want to watch it again. It's so pretty. I'm really happy with this. I mean, of course, there are several improvements that we have to do to this, but like actually labeling the axis and stuff. So we should definitely do that. But in generally speaking, this conveys the concepts that I want to illustrate pretty well. Shows exactly what I want to show. And I don't even think there's too much additional explanation that is required. As soon as I like label the axes and stuff, maybe some text here or something like that, it's actually pretty self-explanatory. The scaling here is the one thing that worries me a little bit, because I should do that correctly actually. What does correctly mean? I should probably scale it by a factor of... Well, if I actually scale it by 1 over square root n, then the resulting thing would be... should fit within plus minus 1. Or I mean, that's the scale at least in which it moves then. Not bad, not bad, not bad at all. Yeah, this was fun once in a while. I haven't done animations myself in quite a while. What do you say? Like a rotating 3D tree. Let me try. I'll make a different scene though, because this one is I want to modify this one. I'm happy with this. One more. Sweet. Pretty sweet. So let me see whether I can do something about your rotated tree. Let's make a second scene. Class rotated tree. Def construct. We borrow some of the code from here, mainly to initialize the tree. But we could technically just go and from a composition standpoint, it's weird having the vertical X moved partially off the screen. Yeah, the problem is I think I would need to transform the vertical axis, and I'm not sure how compatible the axis object is with actually going in there and replacing its objects. I feel like the coordinate system might... I think it would be possible actually. Shouldn't be too hard even. So basically what I want anyways is a rescaled to like -3 +3 axis, because the Brownian motion shouldn't really, or the Brownian motion like thing shouldn't really move outside of that anyways. So it might be interesting to look at that a little bit. I'll think about it. Maybe there's a nice way to rescale this. Maybe there's a nice way somehow. It would. Yeah, the problem is I need to shrink the axis somehow. I need to shrink it, and that should probably happen in the step where the difference is taken. So the question is whether I can shrink the axis or transform. We could play around with that. Wait, but first let me try the random tree. So let's use 300 vertices maybe. Layout scale as it is. This is fine. Let's take it larger again. This we don't need anymore. Can be in the center. And actually, let's go back to the situation that we had before, because I like that animation so much. So we remove this. We add the tree, we wait, and then we play T animate change layout of into the tree layout with root vertex thingy like this, and I need to pass this custom dictionary that I had, graph config, and then we play, wait again, then we play T animate rotate, and the axis that we rotate about, so we can rotate by, wait, I should use the rotate animation actually. T by angle 2 pi, and the axis should be the up axis, then it should rotate out of the plane. We'll see. Let's see whether it does something. Okay, changing layout. And rotating. There we go. I should take it longer. I should make it longer than just 1 second. Let's rotate, but slowly. Runtime equals like 4 seconds. Render again. Did you mean something like this? Probably 6 seconds would have been better. Anyhow. What did I miss here? Would it be possible to generate that initial messy graph representation in 3D so that edges don't cross and make it so that was... Technically, it would be possible. The edges not crossing part would be difficult though, because the standard spring layout doesn't support 3D, I think. I think the standard spring layout that we have doesn't support that, so it would be... I could choose a random layout in three-dimensional space, but that would be... Yeah, it would not look as good, I think. I don't think that the spring layout algorithm supports 3 dimensions. At least not in the way that it's implemented in Manim. Yo, here we go. Why is the second? I should have maybe also passed the linear rate function. So is this what you meant, sicher nicht? Exactly. Yeah, yes, you can definitely do that. Not even a problem. In fact, easy. I'll leave the code here. Let's quickly investigate here again. So we could try the following. In this step here, where is it? Where we replace the mean curve with the normalized one. So where we take the difference. We could add a third. We could add a third replacement transform that takes care of that technically. Because I don't think, do we scale the x's at some point? Ah yeah, we make them larger here, don't we? That's annoying, but could be handled, I scaled them by a factor of 2, and before that we scale them as well, don't we? Where is it? Yeah, first we scale it by a factor of 1/2. So actually we scale it by a factor of 1/2 and then back to a factor of 2, which means it actually has a scale of 1 at that point. So what we could do probably is create a second axis set and then only use the y-axis of that and then transform. We could try that. I don't think it might not work exceptionally well, but we could try. So in this step here, we create a new axis set where the x range is like before, 0 to n, with the range set to n so that the ticks disappear. There's probably a better way to make the ticks disappear actually, but well. Y range equals something smaller. We could go until square root of n, but instead reach from minus to plus. That we could actually do. So we could go minus square root. Is that a good idea? I should probably make it an integer. Let's try it. Minus square root n to square root of n. In steps of n, that should also make sure that we don't have ticks. And then we also replacement transform our original axis dot y axis into the x temp dot y axis. That's kind of sketchy. And it might not work in the way I'd like it to, but we can try. The axis might not be in the correct position, and then stuff afterwards might break down. But actually we don't draw anything else afterwards, so it maybe. You know what, let's just try. I'll have to render most of it again. Let's say we continue. Actually, I can look at the last frame. Let's just look at the last frame. Can't convert complex to float. Yeah, okay. That's on me. Where did he import squared from? CMath. Just use math maybe? Easy solution. And actually let's fix the command line arguments, because I feel bad if those are like there. Rendering. We just look at the last frame. It still takes too long. For some reason, the x-axis seems to be gone, and the y-axis is still here, though. That's kind of interesting. Did I transform the y-axis in one of those two cases? No, I didn't. I mean, we could be even more adventurous and just transform the entire axis into the new set. Xtemp. Wait, what did I have here? Yeah, that was actually fine, I think. Sage. Yeah, but these are... I don't think that the axis objects are handling replacing parts of it so well, so that might be... That might just be the way it is. That might just be the way it is. Well, this confuses me now. Maybe I should not use replacement transform. That's actually a bad idea. That's for once a bad idea. Because the plot group here is touched and then the axes get re-added. I think that's the problem. That was the problem right now. But maybe we can fix it. I shouldn't play around with green stuff. While streaming, at least. Yo, show me. Yes. Yes. That's better. That's much better, actually. But the position of the new axis is kind of weird. And that's probably because we don't need to shift anymore. Because if we did things correctly, the axes are already shifted. So we don't need to touch the plot group at all. Maybe. Wait. We do need to touch the plot group. Oh, that's a bit bad. So we can throw the axis out, the old axis out of the plot group. Well, that's kinda sketchy. Let's look at the image, whether this looks correct. And if it does, then no further questions asked. Yeah, I thought so. I thought this would be a problem. So we will have to move the things correctly. The problem is that stuff looks sorta different now. Yeah, I'm not sure. I think I should solve this separately. I was kinda happy with the state of it before I made the adjustments. Let's render the full thing again for like 1,000 again. Why not? Why not? But we could try setting a seed. Wait, how do I set a seed for NumPy? Or for network X, maybe? Question is whether network X, the seed of network X is the same as the seed for NumPy. Network X seed. Randomness. Ooh, very bright documentation. RNGs are often... Did I just drop some frames? Kinda looked like it. Did I start rendering in the background? Oh, it might be the rendering and then using the browser simultaneously. I can't do two things at the same time. What am I thinking? I can pass a seed parameter. I'll pass a seed parameter. Random tree seed equals 42, obviously. We'll check whether it's a nice tree. Wait, I didn't even render. Weird. Let's go again. Oh, and let me disable caching, because I think that's also... Ah, no, I don't want to disable caching with the enabled seed. It was only briefly though. Okay. You can see my computer struggling with rendering and streaming at the same time. Just shaking my head back and forth to demonstrate. Okay, now at least it works, kinda. Yo! With this done, I'm actually pretty happy. What's the time? Past midnight. So I think I will move gaming to maybe another day and be happy that we did this nice animation. And yeah, we'll see. We'll render it once more and then we might be happy. We might be happy. Let me quickly check my Discord and Manim's Discord actually. Ooh, new posts in the Reddit. One of them probably being the error that we fixed with the latest release. Yo, I haven't announced the new release to Reddit and Twitter. I should probably tweet out and write a post. I should probably do that at some point. Oh well, the tiny things you tend to forget. How's this going? Number 4. Almost done, basically. I'm curious what the random tree looks like with seed 42. It has to be a good one, right? Has to be a good one. What I should do, what I should put on the list for the options that we could do next stream is people keep asking me to continue my Manim tutorial series on YouTube. So what I should do is I should collect more material for the next episode. And you could do that on stream as well. It might be fun actually to discuss what my intentions are and how we can do it. I think I'm mentally not able to record the episode while streaming though, so that has to be separate, unfortunately. Would be fun, but there are some parts where I just need footage from the camera, and then that would be kind of difficult because stream output is unfortunately too low resolution. Sad. Yo. So here's what we did today. Here is the product of our last 3 hours. Let's go, show. It's a nice tree, I think I like it. Here we go, chat, here we go. Are you ready? Where's my chat? There's my chat. There we go. Sweet. So that's pretty good. Loop it again. Spiel denselben Song nochmal. I'm happy with this. I'm pretty happy with this. The uncovering tree animation came out surprisingly well. I did not expect that we would manage to do it as clean as it is. So this part on the left here. I thought it would take much longer to write a working version of that, and in fact it did not. It was actually we were pretty fast doing that. I'm happy. I mean, except for the axis stuff in the end, which is kind of annoying, and generally, if I wanted to make this a little bit more self-contained, then I should definitely add like labels to the graphs. But overall, this works well. I feel like the idea of it works well. And to be quite honest, I mean, I don't think that this here needs a lot more labeling than maybe putting number of edges or uncovered connections and here something like, I don't know, connected components or something like that. It can be slightly technical. I intend to use this at some point or something. And then we have the line here, we renormalize. So one thing that I could do is, before we do this, before we insert the second line, I could rescale this entire graph here to fit into the interval 0, 1, 0, 1. Because actually the result that we have proved is when the graph is rescaled in that size, that magnitude. So maybe that would be worth it to just rescale the thing at this point, because here it seems sort of natural when you have the graph and then you change the scale slightly. And then you have the graph, take the difference, move it up and make the difference more apparent. That might be a good way to improve this, but otherwise, this has been productive. This has been pretty productive, I guess. Yo. All right. Chat, sorry for baiting everyone into saying, well, sorry for promising to play games and then not playing games again. I think I've done that like the second time or so. But I feel like that a good number of people are actually here to see Manim stuff, so why not do some more Manim stuff? I'm happy with that as well. I will be back I will be back tomorrow though. Probably tomorrow. Well, it says gaming with a question mark, so technically not a lie. Indeed, if you say it like that, it might have said gaming later in the stream notification though. I'm not sure. I'm not sure. Very cool to see your working process with Manim. Yeah, it's some sort of trial and error based thing, and I do admit, working so much with the library and maintaining it has definitely helped. Well, with a lot of things. Just knowing where I can look stuff up and I'd like to say I have a pretty useful understanding of how the library can be used and the features that it offers. So yeah. Right. I hope you enjoyed this. I can do stuff like that in the future again. There's actually a second thing I wanted to animate. I wanted to make the animation in my one animated emote that I have a bit more apparent, like this one here. And I feel like if it's large, then it's kind of visible, but as long as it's small, it's not really. I feel pretty sorry for my peers at university who come with me with their Manim questions. Don't be sorry. As long as you have answers that and can help them, even if the answers just consist of go look up the documentation. It's helpful still. Pew pew, yeah, that's what I wanted to work on initially today, but then I thought, well, this stuff got accepted, so this work got accepted, so I should maybe make some sort of animation, and then not sure what I will do with it. I will probably at some point I'll give a talk about it, and then I probably use that stuff somehow. We'll see. We will see. I do direct them to the documentation a lot of the time. I think that's the best you can do. We've had someone on the Manim Discord today who asked. It was clear that they were like really on a beginner level and didn't know Python that well yet. So it was kind of tedious to try and help them. Because they needed help with every single step. But well, as long as people are willing to learn and stuff, I'm fine answering questions. Anyhow, thanks everyone for hanging out. This has been a pretty cool stream. I think this animation, this Manimation that we've produced today, pretty sweet. I'll think about how we can further improve it and whether there's something else that I want to show with that, or whether like rendering this for 2 or 3 trees one after the other and then putting it together to a full like a minute video or something like that. Shouldn't be longer than that, but it should be fine. I'll think about it. So yeah, thanks for everyone following today. Welcome everyone who is new to the stream. Hope you enjoyed it as well. I do Manim. Recently I've done more programming than gaming almost, I'd say. But that was because, well, we wanted to make the release and stuff. So I do this sort of stuff regularly. If you enjoyed it, then, well, tune in next time. Follow the stream, and if you really can't get enough, then there's also a Discord you could join, technically. ! Discord or so. So yeah. Games tomorrow, I hope, when I'm back, or in the next stream, whenever. And see you guys next stream. thanks for hanging out as usual. It wouldn't be as much fun doing this if without you guys. So yeah, thank you. Good night, everyone, or nice afternoon or whatever time it is, and see you soon again.